Alright, let's try some radical equations this time and see where it leads us. Now, if you recall, the last time we were solving radical equations, we were always trying to isolate the radical to one side. So we'll start with the square root of x minus 1 plus x equals 7. And our first job should be to subtract x from both sides of the equation. And what we're going to come up with here is this. We're going to come up with the square root of x minus 1 equals 7 minus x. And so we square both sides now in order to eliminate the radical from the expression. Squaring on the left and the right reveals that x minus 1 is going to be equal to 49 minus 14x plus x squared. And since we have x squared in the equation, we must set the entire thing equal to 0. So we're going to rewrite by subtracting x from both sides and adding 1 to both sides. Subtract x from the left and from the right. Add 1 to each side. And we come up with 50 minus 15x plus x squared. Or written another way, x squared minus 15x plus 50. Is equal to 0. Well, in this factorization, we need two factors whose product of 50 adds up to negative 15, and we find that x minus 10 and x minus 5 both work as factors because negative 10 times negative 5 is positive 50, negative 10x minus 5x, and our outer and inner terms add up to negative 15x, so we're doing pretty good. We take each factor, set it equal to 0, we find that x is equal to 10, or that possibly x equals 5. Of course, are we done? Heck no, right? We got to check, so we need to make sure that we check each of these solutions. So in our first case, let's try it with 10, and we always go to the original equation if we're going to check. You can't go to any other version. You can't go to the one that you've squared on both sides or anything else because it won't work. So let's try x equals 10. If we substitute in 10 into our original equation, we should be getting the square root of 10 minus 1 plus 10 equal to 7. Oh, it doesn't, I don't know. Let's see, we got square root of 9 added to 10 would be equal to 7, except that 3 plus 10 does not equal 7. So we must come to the conclusion that x equals 10 is extraneous. So let's try our other solution right here with x equals 5. If we check x equals 5, by substitution into the equation, we should find that the square root of 5 minus 1 added to 5 gives us 7. And sure enough, we're going to find that the square root of 4 plus 5 equals 7 because the square root of 4 is 2. And as we all know, 2 plus 5 does equal 7. And so our solution checks out. X equals 5 is our only solution to this equation. Alright, so far so good. Let's try one more right here. This time of the form 2x squared of 2x plus 1 minus square root of x equals 1. We've got radicals on both sides, so we're going to be busy. So we're going to have to try and square both sides after we isolate one of the radicals. And I'm going to add square root of x to both sides so that I get a new equation, square root of 2x plus 1 is equal to 1 plus the square root of x. And we should now get busy on squaring both sides of this equation to eliminate the radical around 2x plus 1. So doing so on the left reveals that 2x plus 1 will equal on the right 1 plus 2 times the square root of x plus x. All right, well, we're going to have to start combining terms and reduce things out if we can. So we would subtract 1 from both sides and subtract x from both sides. And what we're going to find right here is that x is equal to 2 times the square root of x. Oh, sort of an interesting equation here. What will we do? Well, just like we did before, let's square both sides to eliminate the radical. So if I square x on the left, I will have to square the quantity, 2 times the square root of x on the right, so that x squared is equal to 4x. Okay, now we know a big temptation at this point is to say, all right, just divide out by x. Avoid that temptation. Subtract 4x from both sides and set it to 0. Your job, so as not to miss any answers, is to set any equation containing x squared equal to 0 and then trying to solve it either by factoring or by completing the square or some other method. In this case, if we take x squared minus 4x, x factors out as a greatest common factor, leaving us with x minus 4. And we have two factors equal to 0. Either x equals 0 from our first factor, x, or x minus 4 equals 0, revealing x equals 4 from our second factor. And just like we did before, we're definitely going to have to check. So let's go ahead and check x equals 0 and see what happens. Does that work? If we take the square root of 2 times 0 plus 1 and subtract from it the square root of 0, does that work? Well, yeah. Right, we're going to get the square root of 1 minus 0 is equal to 1. And we all know that the square root of 1 is equal to itself. And so, yes, x equals 0 is one of our legitimate solutions. Let's try the other one. We're going to check x equals 4. So we're going to take 2 times 4 plus 1 and subtract from that the square root of 4 and see if we get 1 as a result. Well, substituting in, or after doing our substituting in, multiply 2 times 4, add 1, we get 9. Taking the square root of 4, we get 2. The square root of 9 is 3. And as we all know, 3 minus 2 does indeed equal 1. And so once again, we found a solution. So in this case, both of the solutions work, and our solution set contains both x equals 0 and x equals 4 in the set. And so now we're done. Okay, more to come.